Because in the colloids, the nanoparticles are suspended. They are not on the bottom, because we don't see a precipitate here, or we will make a jelly solution. We don't see particles. They are very small, because they are nanoparticles. We cannot see with naked eye, okay? So, first of all, I will make also a jelly solution. The jelly solution can be made easier by adding the powder of jelly. I have here already weighted a small quantity of jelly. Yeah. How many of you? A small quantity of solid gelatin. Yeah. And to make the jelly to be used, this will add a small quantity of water. And will warm up. You can see it's not dissolved. Okay? To dissolve this, must warm up the water about 60 degrees, but not to boiling, never to boiling. Okay? And don't take care when you light the glass again, when you work in that. Never to pass through the sample. Okay?
Jó, tudom, jön meg, tudom, jön meg.
Let them pass. So, you see any spot here? No. Okay, this is milk. This is water. So, you can see. Look, I will project also mine. You can see clear the spot. Yes? Yes. You see no spot here. This is diluted milk. Okay? Look from above. You can see the beam. Okay? Yeah. You pass it through also. And you'll see after the jelly. So, if the milk doesn't show up any spot, means that the milk contains something. We didn't allow the beam to pass through. So, we have here some particles we cannot see with naked eye. Or suspended in the milk.
Sorry?
Or suspended in the milk. Okay?
Okay.
This particle. So, basis. Milk contains nanoparticles. The nanoparticles are made from a substance, a protein, called casein. You heard about casein?
Yes.
Casein is the main component, the main protein, who will find in milk. This casein also are bonded with calcium, because we said many times, if you drink a lot of milk, we will have calcium in our body. We have strong bones. Okay? So, the casein is present is the base of the nanoparticles who are in the milk, but these nanoparticles are not alone. There are small association of this nanoparticle, around 50 to 300 nanometers. So when we drink milk, basically we drink nanoparticles, nanocasein particles. Okay, so take care.
Okay.
Do not drink too many milk, because you drink too many nanoparticles.
Sure.
I don't know, it's very healthy. As you can see, it's about, the temperature is about 60 degrees. Okay? So the solid jelly will transform in almost a solution, clear solution. Now, because you heard that.
Okay.
See the beam?
Yes.
Yes.
It's almost like in diluted milk. You see it? Yes?
Yes.
It's more like good. So, next, what we will make is we will change a bit the structure of the nano milk particles. Okay?
Okay.
Because what has happened? All of you know that are many products based on milk, right? Like yogurt. You eat yogurt.
Yes.
Like cheese, right? They are mainly made from milk. Yogurt, milk, and other milk-based products are made from milk, but they contain same nanoparticles like milk. Nothing is added, no other nanoparticles. Only thing is changed in this case is how the nanoparticles are organized in the milk. In the milk are suspended, are isolated, okay? Yeah. But in the cheese, in the yogurt, these nanoparticles start to gather together to make big clusters, okay? To agglomerate. So, when people try to make yogurt and cheese, they must know they do something that will change its organization, to add something that allows the nanoparticles who are isolated to gather together, to bond. Okay? So, for this reason, there are several methods. The simple one is to add something, like, and I will add in this case, a common product. You all know it. It's vinegar. You know about the vinegar, right?
Yes.
Okay. So in chemistry lab, maybe you can remember to talk about the acids or acidity. Yes?
Yes.
The level of acidity. So to make cheese, usually we must make the milk in the first stage more acid. Then to add in the milk substance who raise the level of acidity. Okay? So, in this case, I will add vinegar. Maybe you remember to measure the level of acidity in the lab of chemistry, you can use easily pH paper, because as pH we know a notion base when we can see the level of the acidity from a scale from 0 to 14. If the pH is from 0 to 7, we call it acid pH. If the pH is from 7 to 14, is base pH. Okay?
Yes.
Usually the water we drink all the time, what is the pH of the water? We drink it usually.
7.
7. It must be 7. It not be higher or lower than 7. Okay? If it's higher or lower, it's something wrong with the water we drink it. Okay? Good. So we have the the cold milk, and I will make another sample of warm milk. So in this case, I will warm the milk about also 60 degrees to see the temperature. Have a role in this change of organization of nanoparticles or not? Or is only the acid that plays the role? So measure that level of acidity in cold water. Cold milk, sorry. See how much it is pH there. You can put it on a scale. 1 or 2. How much it is?
7, 6,
Oh! No, it's not that. Because all 4 colors must match. See?
6.
All 4 colors must match the scale. Not just one. When you measure with this kind of paper. Okay? There are different kinds of pH paper. One is like this. This has 3 types or 3, 1, 2, 3 different scales. And for each scale, we can use one type. This is more versatile, let's say, because we have one paper for each scale. So that I will use that. Now, I will add in the old milk a small quantity of vinegar. Okay. I will add the same amount also in the cold milk and the warm milk. 20 milliliters I will add. Okay. And you must observe what will change also in the aspect of the milk.
Can I ask something?
Sure.
What is this?
What is what? Vinegar.
Vinegar. Oh, vinegar.
I don't know how we say now, you're regular. Vinegar is a usual food product. You use in salad. Smell it. Right. Maybe you remember the name. Oh.
Acetos.
Now you see what is, you know what is vinegar? Because all from here we use vinegar. We have it in our kitchen at home, vinegar. It's made from what? Vinegar.
I think it's
Apple.
apple.
Yes, apple. We use, because it's healthy to use natural made vinegar. Usually you can find on the market two types of vinegar. Synthetic vinegar and natural vinegar. Natural vinegar is based on, like your colleague said, apple,
Grape.
grapes. Grapes is easier. We make wine from grapes, let the wine of high temperature to fermentate, and we obtain vinegar. It's easy. Most easy. Okay? The other type of vinegar you can find also in market is not so healthy, because we call it in chemistry synthetic vinegar. So the main component of the vinegar is an acid. In chemistry we call it acetic acid. Okay? Both natural and synthetic vinegar contain acetic acid. But in natural vinegar, acetic acid is made naturally by fermentation of alcohol. But in synthetic vinegar, it's made directly from acetic acid. It's about 5% concentration. Vinegar contains about 5% acetic acid, but it's not natural. So look on the label when you take this vinegar. What is the basis of the source of this? It's natural made or some synthetic made? Okay. Wait. This is warm milk. Okay. Measure the pH also to warm milk. We'll put it here to see the acidity is modified by warming or not.
Okay.
Okay.
Same.
Is the same? Okay. Right. Is there. So nothing happens when we warm the milk with acidity. Okay? But something is what happened. As you can see,
Yes.
after we add vinegar. See?
Yes.
It's no
Longer conditioning.
it's no more clear, let's say, solution. Something, the nanoparticles are starting together to make small association.
Ama sanki yediğinin rengini solmuş
It's more like 6. Yes, you have right. Put it there. Okay, great. And now I will add the same amount of vinegar in the warmer. Also 20. Okay. Never do vinegar like that. Whew. You can see it was a more rapid change in the warm milk than in cold milk. After I add the vinegar, as you can see, it suddenly changed something there. Okay? Now we'll mix a bit and measure again. Also there and also there with different paper, okay?
Herkes anladı.
Whoa, something will change.
Acıda çok.
Let's put this.
4 oldu.
Okay.
Birinci mi?
Both of them is about 4. Both of them is about 4. 4.
Aynı değiller ama.
Four.
4 and 3.
You can see this. So
4.
4.
you decide. I said you decide. Don't ask me. Don't ask me. You must see.
I think both of them is cold.
Yeah.
So this is cold or what?
I said that.
This is cold.
Cold. This is milk with vinegar. Cold, right?
What does it? Cold.
4 dedik ya sen 8 dedin.
And this is what? Right? And how much?
4.
Four.
It's just a different speed.
So, as you can see, look, I'll remove the white one. We started to separate the nanoparticle from the rest. You can see. So,
It looks like sponge.
yes. When people make cheese, they add something who will modify based on the acidity
Aynen.
to separate the nanoparticle. But like you see, I don't add other nanoparticles. I add only vinegar to modify the acidity. So basically, milk, yogurt, cheese are all composed by nanoparticles, same nanoparticle, but different organisms. Okay?
Like diamond are cold. Like diamond are cold.
Like diamond.
So when you eat yogurt, milk, and so on, you eat nanoparticles. So when you eat like breakfast milk, we eat nanoparticles, you eat nanomaterials, so it's related with nanocount very much. Okay? Thank you very much for your attention.
You can.